In this example, we're going to look at some cross-section areas. So a region is the base of a solid. Each cross-section perpendicular to the x-axis is a rectangle that has a height 3 times its width. So imagine drawing rectangles up off of this, like that. Okay. So imagine, I'm not drawing them particularly well, but imagine these rectangles being built off of our shape. So I always think of a rectangle, I start by just drawing the shape. I've got a base, and I've got a height that's 3 times the base. So the area is 3b squared. Well, how I get the base, of course, is using the function. So I could rewrite this as 3 multiplied by the difference between the two functions. So f of x minus g of x squared, because f of x minus g of x is the width of my base. So that's what I'm going to integrate. I'm going to have 3, I pull that up front, from negative 1.995 to 0.639, f of x minus g of x squared. Now, let me just explain the difference, because people will usually look at this and say, well, this is different than a revolution, because a revolution is f of x squared minus g of x squared. Exactly, because in a revolution, make a little note up here, when you're doing a solid of revolution, your cross-section, when you spin it around, spin something around, it ends up being a circle. And to find the area of that circle, you do pi times the big radius squared minus pi times the little radius squared. But this isn't a revolution. Our shape in this case is a rectangle, and the area of the rectangle is just 3b squared. So you'll notice, here's our area, and here's our area. All we're doing is integrating the area. In this case, how we got the area, and usually you'll see the pi factored out, is by finding the difference between the two circles, the difference in areas between the two circles. Here, we found the area by simply doing 3 times the base squared, where the base was just how far apart the two functions were, the difference between the two functions. Okay. Now, in this last example, it says each cross-section perpendicular is a semicircle. So let me draw a semicircle. I always like to just say that area is 1/2 pi r squared. Well, this distance between the two functions up here doesn't tell me the radius. That tells me the diameter. Okay. So because of that, I have to take that difference and divide it by 2. So I've got 1/2 pi times the difference between the functions. That's the diameter, and I divide it by 2. So I'm going to integrate this to get the volume. So bring that constant out front. And I'm going to have the radius squared inside here. Okay, so cross sections are a little bit different. Revolutions always have this circle where it's the big circle minus the little circle if you have two equations. But cross sections require you to kind of think about the shape and think about, okay, like in this case I didn't know the base. How would I write the base in terms of the two functions? Well, it's just how far apart they are. In this case, the difference between the two functions told me the diameter, so I had to adjust that to get the radius.